wanted to do a live masterclass today. My name is Dr. Steele. So welcome. I'll give people a couple of seconds to go ahead and join. Today, again, we're just going to be doing some algebra for about an hour. So get your pen and paper and let's get ready to go. Unfortunately, algebra gets a bad rap. A lot. And so what I want to do today is decrease that anxiety, and hopefully you'll leave without thinking math is the worst thing ever invented. So today we're going to cover a little bit about me and then some definitions. The definitions we're going to look at are algebra, variable, expression, equation, and like terms. And then we're going to be combining like terms, and then we're going to solve some equations. So a little bit of math humor. Why did the Romans find algebra challenging? Get it? Because x was always 10. Get it? Roman numeral, x always equals 10. Oh, I cracked myself up. I might be the only one laughing, but I find it hilarious. All right, a little bit about me. I was born in Albuquerque, New Mexico, where for us older, more mature adults, where Bugs Bunny made the wrong turn, or for the younger crowd, and us too, where Breaking Bad was formed. I went to Sandia High School, where I did marching band and concert band. In the marching band, I played the bass drum, and in the concert, I did all those clarinets except for one. I also did volleyball, basketball, and track. Then I said, I need to get out of Albuquerque. I gotta get out of New Mexico. And I went clear across the country to Maryland, where I went to Bowie State University, which is an HBCU, and I got my bachelor's degree in math, and it's where I also became a member of Delta Sigma Theta Sorority Incorporated. So I lived in Maryland for about 7 years, and I taught high school. Then I went, let's go to school some more. So I went all the way down to Orlando, Florida, where I went to the University of Central Florida, and I got my master's and Ph.D. in math education, which basically means I can teach math content, and I also teach teachers how to teach math. And I've been lucky enough to travel around the world. I've hit about 20 countries. I basically am on that side of the world because I was fortunate enough to teach in China and Abu Dhabi, which is about an hour outside of Dubai. And I've seen 5 of the 7 wonders of the world. A little other things that I've done. I've taught college, I've taught high school, I've taught both face-to-face and online. I was the math director for 24 charter schools. A little bit of stuff. You want more information, you can check out my website, drbjsteele.com. And also, also I realized through my, 18 years career that I love helping people. And it just so happens that I know a little bit of math. So that's typically how I help people. All right, enough about me. Let's talk about what you are here for. So the technical definition of algebra is a generalization of arithmetic in which letters representing numbers are combined according to the rules of arithmetic. I know that sounds really complicated, but it's really not that bad. Just think about it as having some letters that represent some numbers, and you put them together, and you have algebra. Now, unfortunately, algebra gets a bad rap because it's typically the first time you'll see a letter in math. And people say letters aren't supposed to be in math. Math is all numbers. Well, these letters are called variables, and they are literally just representing a number. So we have variables that can be any letter. Commonly, we see a variable x as what's being used, but it can be y, q, m, z, elemental p. It doesn't matter. Any letter can be a variable. So let's look at a common thing you might see in an algebra class. X plus 3 equals 5. Now, the x is what we call a variable, and it is representing some number. So in the equation x plus 3 equals 5, you can ask yourself, what number plus 3 is going to equal 5? Or another way, make this equation a true statement. We all know that 2 plus 3 equals 5. And so what we can say is that this x is representing the 2. So x equals 2. All right, let's look at a couple more definitions. Let's look at the difference between an expression and an equation. An expression is a combination of numbers and letters, and you have to have at least one operation. So let's look at some examples. X plus 3. Do we have a letter? Yep, X. Do we have an operation? Yep, plus. And then, of course, we have the number 3. So this is an expression. U3y minus 7 also. And then the last one, you'll see a combination of operations and different letters representing different variables. So that's an expression. Whereas an equation technically is an expression with an equal sign. So here are some examples. So if someone asks you what's the difference between an expression and an equation, you can say an expression doesn't have an equal sign and an equation does have an equal sign. And they both have a combination of numbers and letters and at least one operation. Now, it's very important to realize that with an equation, that equal sign literally means equal, right? So if you have a balance scale, it's going to be balanced because the right side equals the left side. We'll get into that a little bit more later. All right, now let's talk about another thing you'll see, like terms. So like terms are terms that contain the same variable, and that's going to be raised to the same power. Now, being raised to the same power is key. So some examples of like terms would be 2x and 5x. They're like terms because they both have an x. Now, if you notice, the numbers in front, which we call coefficients, the 2 and the 5 are different, and that's perfectly fine. In order for it to be a like term, it has to have the variable needs to be the same and raised to the same exponent. Another example, 8r and negative 3r. They both have the variable r. We have 6n squared and 23n squared. Now notice they both have n squared. We could not combine 6n and 23n squared because those are not like terms. So that exponent has to be, the exponent and the letter have to be the same. Now the last one, 9wq and 4wq, we have two variables, but notice we have the same two variables, and so they're both like terms. Now technically, you can do 9qw and 4wq because they still have the same variable. The order is different, and that's okay. But our like terms just need to have, again, the same variable raised to the same power. So now let me put you to the test. I want you to choose the like terms that you see on this screen. Do 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 do. All right, time is up. Let's see how you did. So one pair is 3w and 6w. Another pair is negative 2x to the fourth and negative 9x to the fourth. Another pair is 2x cubed and 7x cubed. Now notice the 2x cubed and 7x cubed cannot be combined with the negative 2x to the fourth and negative 9x to the fourth. Why? because those exponents are different. They have to be the same. And then the last pair, negative 22wx cubed and 78wx cubed. Also note that those two cannot be combined with the 2x cubed and the 7x cubed because they also have the w. So everything needs to be exactly the same for them to be considered like terms. So the next step would be to combine all of these. So what I've done is I've rearranged them and I've put all the like pairs that you just found together in a very long, is this an expression or an equation? A very long expression. And so when you combine like terms, what you're going to do is basically take the operation and combine them. So we have 78wx cubed minus 22wx cubed. So that will leave us with 56wx cubed. And then the next two that we can combine, negative 9x to the fourth minus 2x to the fourth is going to be negative 11x to the fourth. And then 7x cubed plus 2x cubed is going to be 9x cubed. And then 6w plus 3w is going to be 9w. Now notice on this last line, there's no more like terms that can be combined together. And so that would be our final answer. So combining like terms isn't too bad once you understand exactly what that means. All right, here comes the fun stuff. So let's do some solving of equations. So before we had x plus 3 equals 5. Now, again, notice that when we did this, we know that x plus 3 equals 5. But let's say it's a little more difficult. What we're going to do is get this x by itself because we're trying to figure out what does x equal to make this equation true. So what I want to do is basically undo what's being done. You have to unlearn what you have learned. Sorry, you don't get that. Don't worry about it. Negative 3 is going to be the opposite of positive 3. So we're going to subtract 3 from both sides. Negative 3 plus 3, they cancel. And 5 minus 3 is 2. So we know that x equals 2. And what's the great thing about solving equations is you can always plug this back in to see if it makes sense. So if I put this 2 in for x, I want to see if that equals 5. And it does. So 2 is the correct answer. Let's look at another one. Okay, so you probably can figure out what number minus 10 is going to give me 30. But just for fun, let's say you can't. So again, we're going to get this variable by itself. And to get the variable by itself, we need to perform the opposite operation of subtraction, which is addition. So we're going to add 10 to both sides of the equation. Now you might say, well, why are we adding it to both sides of the equation? Good question. Because when you have a balance scale, if you put 5 pounds on one side of the scale, you have to put 5 pounds on the other side of the scale to keep it balanced. So whatever you do to one side, you have to do to the other side because we need to keep it balanced. And so that's why we're doing things to both sides. When I say both sides of this equal sign. Okay, back to the problem. So we're going to bring the x down. Negative 10 plus 10 cancels out. And then 30 plus 10 equals 40. And again, we can check that. So if I replace the x with 40, 40 minus 10 equals 30. All right, so that's a couple of examples of solving one-step equations. So let me give you a couple and see how you do. Let's do excuse me, I keep clearing my throat. I'm getting over something. Now, again, you can probably do these in your head, which is perfectly fine. But for practice, go ahead and write these out and solve them like how I did the previous two examples. All right, let's see how you did. So again, we want to get this x by itself. So the opposite of adding is to subtract. We're going to bring down the x. Positive x and negative x is 0, so they cancel out. And then 30 minus 5 is 25. Did you get it right? All right, then the next one, again, we're getting this x by itself. The opposite of subtracting is adding. So we're going to add 2 to both sides. And sometimes people like to put a line down here so they can keep track of both sides, so they can keep the equation equal. Doing it with the line and without is perfectly fine, whatever works for you. So we bring down the x. Negative 2 plus 2 is 0, so they cancel. And then 22 plus 2 is 24. All right, so that's a couple of one-step equations. Let's look at some that are dealing with multiplication and division. All right, so it's the same thing. Let's say we have 2x equals 12. Now, whenever we have a number and a letter that are right by each other, that means you're multiplying them. And so the question you can ask yourself is 2 times what number equals 12? And again, we know that's 6. But if we didn't, this is how we would figure it out. 2 times x. So we're going to think of what's the opposite of multiplication? Division. So we want to get this x by itself, and so we're going to divide both sides by 2. And you might say, well, how does that even work? Recall when you have a number divided by itself, it equals 1. So 2 over 2 is going to equal 1. And we could technically write this as 1x equals 6. But if you have an x, you have 1. So we don't write the 1 in front. So you would just write x equals 6 for your answer. And a nice thing again is you can always check it. So if I replace the x with 6, I have 2 times 6 equals 12. And that works. All right, now let's do x over 3 equals 4. All right, again, we're trying to get the x by itself, so we want to do the opposite. So instead of x divided by 3, we want to multiply both sides by 3. So if I multiply this side by 3, I have to multiply this side by 3. Now, Whenever we multiply fractions, we multiply straight across. And 3 is the same as 3 over 1. So if I multiply straight across, I have 3x over 3 and then equals 12. Now, as we just saw with the previous example, when you have a number divided by itself, it's 1, but we don't have to write the 1. So our answer is going to be x equals 12. And then to check, 12 divided by 3 equals 4. That is correct. Now, sometimes you might say, but that's a fraction. How do you know it's division? It's the same thing. So if I have x divided by 3, it's the same thing as x over 3. All right, so either one is the same thing. So you might see it represented either way. All right, let me give you a couple for you to practice. Let's see. 3x equals 30 and x over 2 equals 5. All right, so go ahead and solve those. Again, you can do these in your head, which is wonderful. But what I want you to do is to actually write them out. Now, y'all stop just staring at the screen. I said write them out. Please write them out. And if you're watching the replay, don't just fast forward till I give you the answer. Do it. That's how you know if you're getting it. All right. So, again, this is 3 times x. So the opposite of multiplication is division. So I'm going to divide both sides by 3. 3 over 3 is 1. So we have x. And 30 over 3 is 10. And then for the next problem, we have x divided by 2. The opposite of division is multiplication. So I'm going to multiply this side by 2 and this side by 2. Again, I can write 2 as a fraction and represent it as 2 over 1. Now, another way that you can think about it is, if you recall, we can cancel the problem out. Those 2's right there. And so we have x equals 10. Now, in the previous division example, I wrote out that next step, and that's perfectly fine if you want to write that step. And it's also perfectly fine if you want to cancel it here. Whatever works best for you. All right, so those are one-step equations. Let's do a little bit more and do two-step equations. So literally the difference is the ones that we just did, you had to do one thing. And the ones we're about to do, you have to do two things. All right, so let's see. 2x plus 4 equals 10. All right, this is a little bit more challenging. You might not be able to do this right away in your head like you could do some of the other problems. But let's break this down. The first thing we want to do is move the number that is not attached to the variable. Now, technically, you could do that many different ways, but this is the best way to go. So when I say attached to the variable, this 2 is right next to the variable. So that's what I mean when I say attached to the variable. So the number that's not attached to the variable is this 4. Again, when we're solving equations, we're trying to get that variable by itself. So we're trying to get this x by itself. And so first thing I'm going to move is this 4. So I'll do this one with the line. Now the opposite of adding 4 is subtracting 4. So we're going to subtract 4 from both sides. And then we're going to bring down the 2x. Okay, positive 4 minus 4 is 0. And then 10 minus 4 is 6. Again, we are trying to get this x by itself. So if I have a balance scale, and on one side I have 2x plus 4, and on the other side I have 10. If I take away 4 from this side, I have to take 4 away from this side. And so you want to keep that in mind. And then the next thing, we have 2 times x. And so we know that the opposite of multiplication is division. So we're going to divide both sides by 2. 2 over 2 equals 1. So we have x. And 6 over 2 is 3. So x equals 3. Again, we can check this. If I replace the x with 3, and when you have a number, two numbers together, and one is in parentheses, that means you're multiplying. And we want to see if this equals 10. So 2 times 3 is 6. And 6 plus 4 is 10. So that works. All right, let's do another one. Okay, that's a funny looking 3. It's still funny looking, but we're going to go with it. Let's do 3y minus 6 equals 12. No, let's not do that one. Hold on. Sorry, guys. Let's do 3y plus 9 equals 15. All right. Again, first thing we're going to do is move what is not attached to the variable. I decided to stop using x, so I use y for this variable this time. And so the thing that's not attached to the y is this 9. So we want to subtract 9 from both sides. So we can bring the 3y down. 9 minus 9 is 0. And 15 minus 9. Now, this is how you can do some things dealing with number sense. Meaning, 15 minus 10 is what? 5. But we're not taking away 10, we're only taking away 9. So, what would that mean? See if you can figure out what I'm trying to say. Right. So since 9 is 1 away from 10, then we're going to need to add 1 to what we would get. Now, that didn't quite make sense. It's okay. As long as you can do 15 minus 9, that's all that matters. All right. And then the next thing again, we're going to divide both sides by 3 because division is opposite of multiplication. So we're going to be left with y equals 6 divided by 3 is 2. All right, let me have you do one yourself. All right, so go ahead and do 4s, not a 5, it's an s. 4s minus 2 equals 8. Go ahead and solve that one. And then after you solve it, be sure to check it. You don't even need to see what I write, because you'll know you did it right. Or you need a little more practice. So now you probably got your answer, and you're looking at me crazy because you didn't get a whole number. Guess what? Fractions are also numbers, and it's okay if your answer is a fraction. Okay? It's okay. It's just a number that's smaller than 1. Don't let that freak you out. So, if you didn't do it like I asked you to and you just stared at the screen, you don't know what I was talking about. But let me show you. Again, first we're going to move what is not attached to the variable. So this -2 is not attached to the variable. So I'm going to add 2 to both sides. And then I'll have 4s. -2 plus 2 is 0 equals 10. The opposite of 4 times s is dividing both sides by 4. So I'm going to divide both sides by 4. 4 over 4 gives me 1. And we're going to have s equals 10 over 4. Yes, 10 over 4 is the correct answer. Now, I should go a little bit further. We're going to go one step further because I can't leave this on. It's not simplified, which means in lowest terms. But I'll let you leave it as an improper fraction. If you want to learn more about fractions, send me a message to my email address and I'll do a video on fractions. But we are going to divide both sides, or not both sides, the top and the bottom by 2. Again, I'm doing this because I want to get this in simplest terms, which means I want to not be able to divide anything, divided by anything else that's the same. 10 divided by 2 is 5, and 4 divided by 2 is 2. So 5 over 2 would be my final answer. And if you did go back and check it, great job. I'm not going to check this one today. I'll wait until I do the video on fractions. I just want you to keep in mind that everything is hard before it is easy. I know, unfortunately, sometimes math can be very frustrating. You want to just keep practicing, and if you need additional help or additional time, that is perfectly fine. You know, sometimes when you see teachers going over content, think about this. I do this every day, all day long. So hopefully I know a little bit about what I'm doing. And I'm pretty sure that something you do every day, all day long, you could teach me. And I might not get it right away. And that's perfectly fine. I'll just keep asking you questions till I do. Let's have a little bit of fun. Since you already have your paper out and your pencil, I know you're ready to go. Now, if you need your calculator, that's fine. Go ahead and get it. But hopefully you don't. So let's do a little fun here. I want you to pick a number between 1 and 10. Don't overthink it. Just pick the number that comes to your head. Now multiply that number by 2. Now take that number and multiply it by 5. Now divide that number by your original number. In the last step, subtract 7. Now I'm focusing on going through the computer, through my webcam, into your brain. And I think it's coming. Yep. I bet your number is 3. That's the answer you got. I have powers. No, I just have math powers. This is all possible because of algebra. Seriously, that's really why you always get 3. Now, hopefully you've enjoyed this masterclass. If you would like to spend a little bit more time with me, I do have some extra things you can do. One is a VIP day, or should I say a VIP experience called Math Superstar. And I know sometimes people need help with content, whether it's for a high stakes exam, like the Praxis or the SAT, or just help in general. And they go and they search for videos just to find out that they've watched a video for an hour that's not what they actually needed help with. So I made this VIP day experience to help with those type of problems. And so what we do is depending on what you're needing help with, I will make an assessment. You'll take it, and then based on how you do, we will make a customized plan for you to go through and learn the material that you need, which is wonderful because, again, if you are just searching videos, you might see something then that you not know, and you waste time watching stuff you already know. But when we do it this way, it is super customized. So it's 6 hours total, and you can break it up in one of 3 different ways. You can do one day for 6 hours. You can do 2 hours for 3 days, or you can do 3 hours for 2 days. And then we'll have a nice recap. You'll get a video, and you'll get a reference sheet of what we discussed. If you are interested, please send me an email at drbjsteele@drbjsteele.com and just, say what you need some help in and that you're a little bit more interested, and we'll book a call and talk about how I can help you. So if you're trying to connect with me on social media, my handles for Facebook, Pinterest, and Instagram is at drbjsteele.com, which also is my email address. I'm sorry, my web address. So drbjsteele.com. Check out my website. I also do programs with STEM. Unfortunately, Black women in STEM is only 2%. And so I really want to help girls to gain some confidence and gain some insight into STEM fields. So check out my site if that also interests you. Thank you so much for coming to my first ever live event, live masterclass. If you are not here live, thank you for watching the replay, and you guys have a great rest of your day. Bye.